Okay, yesterday when I told you the fluff questions, oh wait, I'm sorry. Over here, this number 16 from chapter 4. Let's look at it. Chapter 4. I'm looking at the original review, and then I'm going to look at the one that I just gave y'all, which was the combined down to one packet. So when I write this was the original review for chapter 4. Question. Oh my word. All right, so number 16 in the original says this. And it says solve. And then number 16, the one that I just gave you, yeah. Number 16 in your condensed one, call it the mini review. It's in the front section, which means it's chapter 4, but it's the one where I cut and paste. You see my handwriting on it. It's at the very bottom, and I did this on purpose, the way it looks. It says, in my handwriting. Alright, so does everybody know where we're looking? You with me? Yes. Okay, here's why I went in and had to modify this. On the final exam, yeah, these questions are exactly the same. They're the same type. It's a solve the inequality, right? So when I was going through and streamlining it, I'm like, oh, okay, 16 is exactly like the one on the final, so they need to know that one. But then when I went through and made the answer key, this one here, I'll do orange, this particular one is a special case. And the one on the final is not. And so that makes them actually slightly different. They're the same approach, same technique, but your answer in the end, this one is a gotcha, the one up here, and the one down here is plain Jane, straight problem, okay? And I didn't like that because y'all are gonna be expecting a gotcha, and there's not a gotcha. So I changed it on the condensed one that I cut and pasted. And then I thought, well, now they don't know the answer to it because you remember my solutions key is going to have the gotcha on it. So if you'll look at the bottom of that condensed packet, you're going to see where I worked it out. And I did it at the very bottom because I was hoping you would cover it up and try the problem on your own. Now I'm going to work both of them right here just to show you what I mean by the gotcha. But the one that you need to be able to do is this one. They're the same approach. I guess I could have mixed those up in a different order, but it is helpful to have them in standard form so you can actually see what you're working with. If you take this, compare it to this, what do you notice is the big difference? There's a negative leading coefficient. And it's really helpful if you will get rid of it up here. We don't have to worry about that down here. So there's the first gotcha. So when I go through and multiply this whole thing by -1, what happens to my inequality sign? It's going to flip. So I end up with that. And then you would solve that like it's a regular equation. Well, this factors nicely. Factors of 100 that add to -20 would be -10 and -10, right? At this point, you're supposed to be treating it like an equation. So what's the 0 that comes out of that? 10. but it's repeated, and that's why this one's tricky. So you get x equals 10, you get it twice. You go to your number line, you mark 10. Is it open or closed? It's open. Then you got to test some points, right? So you're going to test like 9 or 0. You can even test 0. Let's do that. Let's just pretend like we're way down here. We're going to test 0, and then an 11. When you test 0 up here, I like to go back to the original. That would go away, this would go away, and this would go away. So it's negative 100 less than 0. Yeah, so this was true. Then when you test 11, you can type that in, I'm not, you're going to get a true statement. So that's where the gotcha comes in, because it's like, okay, now wait a minute. The entire number line is shaded except 10, which is the solution to this. It's everything except 10. And if you were to go that technique that I told y'all, which is just graph it on the calculator, right? And just look at where it's either above or below. If you do that, it's gonna fill off because the entire graph is either above or below, depending on which one you use. So that bothered me, so I changed it. So now look at the breath of fresh air right here. Same approach. We don't have a negative in the front. We don't have to worry about multiplying by negative. Factors of negative 24 that add up to 2. 6 and negative 4, right? So what zeros come from this? Negative 6 and 4. And so then you go to your number line, you plot them, open or closed. Look right here. It's open. And then pick some numbers to check. I'm going to pick 0, 5, negative 7. I like 0 the most. If I put 0 in there, all that's gone, right? Is negative 24 greater than 0? Nope. So that's false, which tells me that the outside should be true. If I was to graph it, I would see that the outside is what's above the graph. Y'all see the difference in those two problems? And that's why I changed it. So, I hope that helps. Because I didn't want to gotcha like that, sneaking in, and then it not be on the final. Like if y'all are studying for a gotcha, I want it to be on the final as well, so that y'all aren't overdoing it. No, I think that was yours, wasn't it? Didn't I? No. I handed it back. Okay. Well, it's just 20 problems, and so like number 1. So if we're starting, let's just go through and we'll just say, does anyone have any questions? Okay. So go to the very first problem. This is the entire, okay. So Jace, you need to come get this. Or I'll come to you. So, you may or may not want this. I went through the chapter 4 and 5 and I cut every question into pieces. And then I threw away the ones I told y'all to skip. And then I glued down the ones I said that you need so that it was in a single packet. Okay, so if you want to throw away the chapter 4 and 5 questions packets, you can, because those exact questions have been copied right here. But what I would do is at the top of this, I would definitely put mini review. I forgot to write that before I copied it. that way you know this is everything all in one. Yeah. I also, what I was just telling them was I changed number 16 because of what I just read. In the original in black, it was a gotcha because it was a special case, but on the final it's not. So I didn't want it. Like I wanted it streamlined. Well, it's the same topic and the same approach. One's a gotcha and one's not. So I changed it to one that's not a gotcha. This is the answer. So. All right. Yeah.
So, is number 9? Okay.
We need to talk about number 9. Go to the mini condensed review. Number 9, right here. Go with me. Bailey caught. I knew it was going to happen because I was trying my best to make sure it didn't happen. I knew something was going to mess up. Bailey caught the number 9 slipped in the review, and it was not on my thing yesterday where I said, like from chapter 4. There's no 9 here. And the little slip of paper was in the stack as I was frantically gluing and trying to make things nice and organized for y'all. So now, but I'm going to ask you a question because let's look at 9. I'm going to highlight it in yellow so it stands. Ooh, that's too much. So it stands out because of the reason that we just said. That it was not actually listed, but it slipped through the review. And I'm going to let y'all vote. Suppose a polynomial function of degree 4 with rational coefficients has the following given numbers as zeros. What are the others? Okay. So one of the zeros is I. One of them it says is I, and then the other one it says is 4 minus square root 13. What's the answer? The answer would be negative I. Only change the sign of the radical. 4 plus square root 13. That would be the answer. Do you want to leave this question on there, or do you want to omit it? It is not on the final. There is a question on the final that is like, here's one given zero, find the rest, but it's an actual where you got to do synthetic division, and you do come down to more answers. It's not, here's a few of the special zeros, tell me the secret hidden ones. That's not on the final. But that's kind of a, y'all vote.
That exact question?
Huh?
You're asking that exact question. Yeah.
I'm asking, do y'all want me to leave that since it's in the review packet? Do you want me to leave it on the test? That would be, I would say, one of those buffer questions that you should not get wrong. Okay. Because the answer here would now.
It's literally negative.
Remember that anytime a zero has an I or a radical, there's a secret zero right behind it that is just a sign change of the I and the radical. Don't change the 4. The 4 is not an I, it's not a radical. Like, only change the sign of the I and the sign of the radical. So the answer to this would be, you could type in negative I and comma 4 plus square root 13. So yes, leave that on there. Okay. Maybe go to your little pink half sheet if you struggle with that and make a note. Only I and radical zeros have a secret other zero, and you change the sign of it. Now I want to go back to the number 1 question, or 2, I guess it's number 2. No, number 1. All right. So, and by the way, today's a regular day. Now, I did hear, I think they were going to possibly change the bell schedule a little. Did I hear that correctly? So, you If your second block teacher allows you, you're welcome to come down here to do like a study hall. That's my planning. I have flex. You're welcome to come down here. So, use that time. All right. Look at number 1. Make sure you know what the questions are asking. Determine the leading term, the leading coefficient, the degree, then classify it. I thought you would appreciate this question because there's no math involved. It's just pure memorization of where's the leading term, what is a degree, what does the degree mean. Has everyone tried it? I don't want to just throw the answer on the board. Does anyone have any questions on it? The only trick on this one is it's never presented in standard form. That's the trick. They're looking for you to jump straight to that very first term in the front. So the trick is it's not in standard form. So before you can answer the question, either get it in standard form or just find the correct leading term and focus on it. You can answer the entire problem by simply recognizing that plus x cubed is the leading term. You can ignore the rest of the terms. Okay? What is a quartic, by the way? What degree is a quartic? That is degree 4. What's a constant? I don't think this would be in there because it would be boring. But the constant is when it's just a number with no x. So those are the only two that I think you might not remember. But I don't see a constant being your question because it would be really boring. All right, go to question 2. This leads right into the same thing. This one is tell me which graph in behavior down here describes this polynomial. Watch out. Think of that GPS. It is not in standard form. They're trying to trick you, right? So focus your attention on the term and the sign and the degree with the highest exponent. This is that whole either it's a quadratic or it's an even degree or it's. Thank you. Just had to hit that one more time. Saturday Night Live. It's fever. Yeah, fever. Thank you. Live fever. Yeah. So Saturday Night Fever is when it's an odd degree, right? And the mother function for Saturday Night Fever is right up, left down. Hit the pose, it'll help. And then if the leading term was negative, it would flip. But in this case, my leading term is even degree, which should make you think, oh, like a parabola. And then you look at the leading term sign, and it's positive, so it's definitely opening up both ends, right? So A. This was another one of those questions I thought you would like to be on here. It's what's the zeros and what's their multiplicity? But they're giving it to you in factor form, which means you don't have to do any factoring or anything like that. You're not solving. It's can you read it in factor form and state the zero? And then the multiplicity, remember, comes from the exponent, right? Now, the trick here is you don't just type the numbers in wherever you want. You've got to pay attention to it's right here. You do need to write the zeros, and then, of course, as you enter your answers, make sure you put the smaller number up here, the middle number here, and the larger number here. That's where most people get those wrong. They overlook that whole small, medium, large. Yeah, have you tried it yet? You didn't enter the numbers in the small, middle. Okay. So what I would do is I'd go over to the side. So if you look at it, is this a zero, y'all? Why is it not a 0? Why can I ignore it? Because it doesn't have an x. If it had an x, it matters, but it doesn't. What 0 comes out of this? Positive 1 with what multiplicity? So I'd make a note, you've got that there's a 0 of 1 with multiplicity 4. Then I'd keep going. So what's the 0 here? That would be a 0 of negative 4 with a multiplicity of 3. And then what's the 0 here? 0 with the multiplicity of 2. And then so now as you enter your answers, you're gonna do this one as your small. Does it say middle? Yeah. So then middle would be here. And then this one's your large. And that's how they want you to enter it in the boxes. And you don't type x equals. You just type the number. Okay? Now, if you actually or accidentally forgot that, I would go in and give you credit. All right, go to the next one. Use the leading term test to test your knowledge. I realized that as I copied this, it became harder and harder to see these particular graphs. So let me help you out. I don't know if you want to get a highlighter. This one's right here. This one is here. Oh, Lord. I think that was it. Is that Saturday Night Fever? 4. Yeah, I think this one has like a weird hook and ladder, like right there.
Yeah.
This is like coming up, doing that. This one. And then this one. Alright. So, now that you can actually see, it's saying, using the leading term test, which once again means focus on that leading term. And in this case, they've nicely put it in standard form. Deduce which graph would be that polynomial. So it all comes from the degree, which is the exponent, and then the sign in front of the leading term. So this is degree odd, which implies Saturday Night Fever, which the mother function is left down, right up, right? Looking in the front, the leading term's sign is positive, which means leave it alone, right? Now the next part, does it come into play? The next part is recognizing that what degree it is. What degree is this one? It's a 5th degree, right? Left down, right up. So we know that it can't be, it's not this, that's the same. It's not this, that's the same. That's the same. We said Saturday Night Fever, which meant left down, right up. So these are, so it's got to be C. Y'all see that? What if, I don't think it's going to happen, but what if it had that negative in front and we were down to those two? It would be F because, look at if you recall, if it has degree 5, that means it can have up to 4 turning points, and it could mean they're kind of crazy. Like if you look right here at this one, it looks they're probably calling that like 4 turning points there. So this looks like a nice smooth x cubed problem that's just stretched out. This looks weird. So I would say if it came down to that, it would be F, but that's just a what if. You would also have your calculator. So if you type that in y equals, right, that polynomial, you could definitely go to your graph and distinguish between those two as a buffer. Like if you narrow it down to 2 and you're really not sure, type it in y equals, okay? Because there's a huge difference between those two, and your calculator will show you which one it is. You can also see the window is standard. It's 10. All right. We already talked about number 9. Y'all decided to leave it on there. It's a nice question that you should have no problem with. Let's go to 12. 12 is taking us right into number 14, which is the humdinger. No, 7's not one of them. 7's on 5, though. Question 12. Determine the domain of the function. Remember, domain means tell me what's allowed to be plugged in, or tell me what's not allowed to be plugged in. Well, it's a fraction. What's the rule in math with fractions? You cannot have a 0 in the bottom. The denominator cannot be 0, right? This is what you need to think. Okay, denominator cannot be 0. So, to find the domain, I need to find out when the bottom is 0, so then I know what's off limits. So, set the denominator equal to 0 and solve. So we've got 3x plus 24 equals 0. So x cannot be negative 8, right? Think for a second. Now, in the answer, though, I believe, how do they have you type it? Yeah, it's just a blank box, and it says type your answer in interval notation, which means if I solved the bottom to find out that x cannot be 8, then my interval notation would imply an entire number line highlighted, and I'm skipping over the negative 8. So negative infinity, skip over negative 8, and that would be your answer. Which takes us to number 14, which is the one I would really suggest adding to your half sheet to remind you of all the different things that you have to do to solve 14. 14 is, here's your polynomial, answer every one of these questions. I'll be honest, 14 stresses me out because I don't like seeing all of these listed. Like, there's no breaks, like I can't distinguish the answer choices from one to the other. So I can't stand 14, but it's on the final. If you've looked already, what is this? This is from 4-5. On the final, like number 4 is what's the vertical asymptote? Well, that's what, second question here. I gotta highlight. I can't even. I read this and my eyes get lost. All right, so that one's domain. This one is asking about x-intercepts. It doesn't even. So this one's x-intercepts. This one is y-intercept. This one, there it is, vertical asymptote. This one's horizontal. And of course, they're going to put this here, but remember, if there is a horizontal, there's no oblique. Remember that. They don't both exist at the same time. I think that's it. And then graph it. Okay. So I don't know if you want to highlight that like I just did to kind of help you see. But anyways, on the final, number 4 is find the vertical asymptote. So that's directly related to this. Number 9 on the final is graph the function and show all asymptotes and tell me where the intercepts are. Now, it is multiple choice. It's not like this crap here. It's completely multiple choice if you're looking at the final exam review. But you do need to know where the asymptotes are in order to be able to figure out the graph. Let's see, I think there's another one. No, there's not. So those 2 from the final. So going through this right now. What's the domain? Well, you just did that. Have y'all tried it?
She's positive for, right?
There's 2 numbers that would make the bottom 0, so they're both off limits. Even though there is a hole here. This one does have a hole. How do I know it has a hole? The binomial on top is one of the factors to the polynomial on bottom. So if you look at this, get it in factor form. Do y'all remember difference of squares? Difference of squares is when the 2 terms are perfect and the number in between is, the sign in between is negative. So x squared minus 16 factors to what? X plus 4 and x minus 4. There's the hole. Right there. So we'll change colors. That is a hole. Think of it as, because when you go to strike it out, it's leaving a hole in your problem. So my new, I'm going to change to green, because now this is what I'm going to focus on. My new problem is there's nothing on top, so it's a 1. And on bottom, I have x minus 4. Now, while I'm going to focus on that, the hole still matters with the domain, because should I plug negative 4 in, I'd have a problem. Right, Houston? So right here, what's the domain? Well, if you think about it, x cannot be 4 or negative 4. Can't be either one of them. So I'm going to have to write an interval notation showing the whole number lines highlighted, except I'm skipping over negative 4 and I'm skipping over positive 4. So that would look like this. Which number gets skipped over first? If you're reading it left to right. Negative 4. Then negative 4 would run to positive 4. Then 4 would run to infinity. So that's how the domain would look. Now, I skip around. Once I know the domain, then I go straight to the vertical asymptotes. I don't like doing the intercepts next because it messes with my rhythm. Because the domain is directly tied to the vertical asymptotes, right? Except the hole. Don't list the hole as an asymptote. Remember that stupid phrase from Lamar Ryland? You've got to know your asymptote from a hole in the graph. You got to know the difference between the 2. While both of them are in the domain restrictions, only one of them is an actual asymptote, and that's the one that's left over in green. The hole is just, think of it as the hole on the number line when you're shading for domain, like you're just skipping over it. So what's the vertical asymptote? You have to read these carefully. This says there's none, this says there's 2, this says there's 1. There is only one asymptote here, and it's where? At what comes out of that? the green. It's at x equals 4. And then I usually go next to the horizontal asymptotes. We'll come back to the intercepts. Remember, the horizontal asymptotes are where you check the degrees. Check degrees. You're checking the degree on top and on bottom. You are looking at your new polynomial, not the original. Of course, it would still be the same thing, but you're looking at the new one. So you got 1 over x minus 4. So the degree on top is smaller than the degree on bottom, right? Because this is degree 0, because there's no x. And then this is degree 1. So I'm going to say degree on top was 0. Degree on bottom was 1, which means the numerator is less than the denominator. This needs to go on your half sheet, the 3 scenarios. Scenario 1 is this one. Numerator was less than the denominator, which means, bam, your HA, horizontal asymptote, is at y equals 0 every time. It's always 0. Second scenario was when the degrees are equal, right? When the degrees are equal, your horizontal asymptote is those coefficients. It's the equation y equals, and then it's whatever the coefficients are. So let's say this had been an x. What if? The degrees would be equal. So my horizontal asymptote would be the coefficients. So it would be y equals 1. You see that? Okay. What if it was scenario 3, where the degree on top is higher? Do you remember what that means? That means there's no HA, no horizontal asymptote. Instead, there's an oblique one, and you do long division to find it. That's the third scenario, okay? I would put those on your half sheet so you don't have to memorize it. That's something I would put on there. So maybe go to your half sheet right now. You don't have to make it perfect so that we can keep going for time's sake, but maybe go to your half sheet and just kind of block off a little corner and put, 3 boxes. So one of them is when the numerator is less than, one's when it's equal, and one when it's greater. And I would put that on your half sheet and then fill it in later, so that way you don't forget.
And there's not going to be no oblique.
By the way, that's horizontal. I should have. There's no oblique question on the final. There's no what is the oblique asymptote here? And then they actually give you one with it. That's not on the final. Now, I can't guarantee there wouldn't be one that would yield an oblique. Right. I don't know that because all the questions are generated by MyMathLab. But there's no specific, on the chapter 4 review, the full one, the one that I gave y'all and said don't worry about now because I've condensed it. I think it was number 13 on the original review. Number 13 was, hey, this one has an oblique. Tell me the equation. That's not on the final. Does that make sense?
But this one could end up having a no horizontal.
Exactly, on the final. Right. So the answer, for this one, ours was what scenario? Yeah, our scenario here was that the numerator was less than. So it's just that there's one HA and it's y equals 0. You do have to watch those answer choices to make sure that you're not accidentally selecting where it says there's. Oh, well, no, if you select 2, then they do give you 2 boxes, so that should catch you.
So can you use the half sheet on the mini exam?
Right, and then on the final, I'm giving you an index card. But I'll give that to you tomorrow. Yeah. Because I don't want you to confuse them. And I'll actually let you keep your half sheet. Like, you turn your half sheet in to finish the test, and then in the class, I'll give it back to you with an index card in case something that you put on there really helps you, and you know it's on the final, you can just copy it to an index card. We got, okay, so once you determine that the HA is this, bam, you can answer the next question, because what did we say? You can't have both of them, so you can't have your cake and you eat it too, you know, that. So right here you would say there's none. If there's an HA, then there is no oblique. If there's an HA, there's no oblique. So easy question there. Now we need to do the intercepts. Please don't forget your basic understanding of intercepts. If it's crossing the x-axis, what's y? If it's crossing the x-axis, y must be 0. So you're going to plug y equals 0 in. If it's crossing the y-axis, then what? X must be 0. Okay, so let's look at it. Go to the original two. You don't want to go to go to your clean one, the green one that is simplified. So for this right here, I'm going to copy the problem. So we've got y equals 1 over x minus 4. Okay, if I'm looking for the x-intercept, I'm plugging 0 in for y. And I end up with this, right? Remember, cross multiply. When you cross multiply that binomial, x minus 4 over to 0, what happens to it? Disappears. And you're left with 0 equals 1, which is not true, which means there are none. Now, had it multiplied nicely, let's say the top wasn't a 1. The only reason this came to this way was because there was no x in the top. What if the top had an x? Well, then you would solve it, and there's your x-intercept. But because the top here was just the number 1, there's nothing to solve. There's no x.
How would you get rid of the x on 24?
It's a proportion. I cross-multiply. What's the opposite of divide by x minus 4?
Yes, I thought you put x minus 4 on one side, and then it'd be like.
But what's 0 times anything?
Yeah, I get it.
You see it? So this would cross multiply up there and it goes away, which is the beauty of finding the intercepts. That's going to happen every time. What doesn't always happen is usually there's something in the top that still has an x. In this case, there's no x left. So this is an example of when there's no x-intercept. That means the graph is either entirely above it or it's entirely below it. You with me? Now we're going to repeat with the y-intercept. We're going to plug 0 in for x. I put 0 on the y. Hold on. There we go. We're plugging 0 in where x is. And we actually come to a number this time. So, how do you write your answers over here in the boxes? Well, here for x-intercept, you'd say there's not one. And for y-intercept, they want you to write the ordered pair, which means parentheses, number, comma, number, close parentheses. I plugged 0 in for x, I got negative 1/4. On the final exam, this type question by? These numbers are a little different. Whoa. There it is. This one looks a little different. I pulled up an old one. And I accidentally on this one forgot to copy answer choices C and D. But this is on the final, how it's presented. It'll say, graph this function, show all the asymptotes and the intercepts, but then it's multiple choice. Which means you don't have to sit there and go through the entire like number 14 process. I would look at it and find the vertical asymptote real quick at the bottom. It will always factor nicely. So like this would be x minus 4, x plus 3, which tells me there's one at 4 and one at negative 3, right? Then I check, that's the vertical. Then I check the horizontal with the degrees. They're equal. So in this case, it's the coefficient. Then I would check the intercepts. This is on the final exam review number 9. Final exam review number 9. Y'all's is the same problem. Perfect. But your answer choices are listed. This one I accidentally cut off 2 of them on this packet. But then you can look at it and see like which ones are crossing. Where's the vertical at 4 and negative 3? You have to be careful. So it's counting by 2s. So that's definitely 4, and that's definitely negative 3. So that one's okay. This is also 4, negative 3. So the vertical doesn't help me here. The horizontal. That would, yeah. So if you look at the difference in those two, do you notice right here, this has a dotted line? That's an HA at y equals 1. Do you notice this one here has no HA shown? See the difference? So that's how you know that, okay, it can't be B, because we just said it has an HA. Then you would check your intercepts. The y-intercept's the easiest one to check, because when you're checking the y-intercept, it means plug x equals 0 in, right? So if you plug 0 in, you end up with negative 1 over 12, which would show me that it's crossing. Those look similar. There's C and D missing, but this is graph A. This particular one. I think y'all's is graph A as well, right?
Yeah.
Is y'all's graph A?
He doesn't have one. Well, no. He has one, bro.
Does B have one for y'all?
Yeah, it's right here.
Look at y'all's, not mine. Don't focus on mine. Yeah.
Okay, I'm going to number 6.
Yep. Wait, which part? 5? Chapter 5? Okay. Oh. That one?
Yeah.
Okay. 2 ways to do it. The algebraic way is that whole find if A equals B. The easy way is type it in your calculator and check if it passes the horizontal line test. By the way, it's going to because it's linear. But enter it in the calculator, y equals, graph it, and you're checking if it passes the horizontal line test. Now, it will pass it, which means you have to say, yes, it's 1 to 1. The second part is, then tell me what the equation of the inverse is. You gotta remember here, that means you're gonna switch x and y and solve for y. Did I make those notes for you? The answer key? I didn't say go to the calculator. I just said, yes, it's 1 to 1 since it passes the horizontal line test. But you would determine that by looking in the calculator at the graph. And it would be x, say it again? Yes, but then you have to solve for y. Yeah, so that's what you would get when you switch it, and then now get y by itself. Yeah, and it ends up being x plus 8 all over 2. Well, they turned the bells off.
You're a mean one, Mr. Grinch.
Huh?
You really are a diva. You're as cuddly as a cactus. You're as
Which
charming
one? Yours?
as an
Ava's freaking out. I
Mr.
hear
Grinch.
she's also band inclined, so her mind's probably counting the song. If let's see, just trying to see if
You have that again.
this is y. You switch them. Now you solve for y.
Oh, yeah.
No, you're not. This is hard. Welcome to college. You can do it.
I'm gonna finish my notes. And I have another call and I'm gonna finish my class with her. That's like 5 hours before. So I'm gonna finish my review.
Look, Valerie, like these two right here, you just type them in.
Yeah, those were easy. I like those.
Okay, there's a lot on there.
I hope it's not